Hello everyone. Now let me continue the nature of a relation. Here I have a second problem, wording problem, to which we have to decide the nature of a relation. Now let me go to the question. Given for a fixed integer n greater than 1, find the nature of a relation congruent to modulo n and the set of integer. Now this is a basic concept where you have studied modulo system. So when you have congruent modulo n, we can write the expression as A is congruent to, this is the symbol of congruency, A is congruent to B mod n. Before solving the problem, I am discussing the basic. So whenever we have congruent modulo n, we are writing the same as A is congruent, the symbol is congruent, B modulo n. Now, as per the definition of congruency, I can write this as n divides a minus b. N divides a minus b. I'll give you simple example. Suppose if I have 9 is congruent to 3 mod 2. 9 is congruent to 3 mod 2. So as per the definition of congruency, I can write this as 2 divides 9 minus 3. 2 divides 9 minus 3. So 2 divides 9 minus 3 is 6. So 2 completely divides 6 3 times. So the value of 9 congruent to 3 mod 2 is 3. Hope it is clear for you. The meaning of A is congruent to B mod n is n divides A minus B. Now, as per the question, we have to test the nature of this congruency relation. That is, we have to decide whether it is reflexive, symmetric, transitive and antisymmetric. Now, first let me solve reflexive. So, as I already told you in the earlier session that as per the reflexive property, we have to choose only one element. Whereas for symmetric, we should choose 2 elements. And for transitivity, we have to choose 3 elements. So since I am solving reflexive, so let me take one element, say A, in the set of integers. Why? Because in the problem itself it is given, we have to discuss the nature with reference to integer. So let me take an element in the set of integer. So now I have to test whether it is reflexive or not as per the congruency relation. So when I'm going to write, so when you're going to take single element, the congruency relation can be written as A is congruent to A mod n. A is congruent to A mod n. So same I can write as per the definition n divides A minus A. Here I have written the basic definition. So when I said A is congruent to B mod n, the meaning is n should divide A minus B. Similarly, I am talking with reference to only one element. So when I am taking A is congruent to A mod n, the meaning is that n divides A minus A. If this condition satisfies, then it is reflexive. Now, how can we verify that this condition is satisfied or not? Now, n divides A minus A is 0. Obviously, this relation is true. Why? Because whenever you are going to give any value to n, obviously it will divide 0. For example, 2 divides 0. In the sense 2 into 0 is 0. So 2 divides 0 0 times. Similarly, 3 divides 0. 4 divides 0. So in general, any number n divides 0. Therefore, I can say A is congruent to A mod n. Right? A is congruent to A mod n. Therefore, R is reflexive. Therefore, R is reflexive. Now, let me talk about symmetric. Symmetric. So, as per the property, when we talk about symmetric, we have to take 2 elements. Fine? Let me take 2 elements, A and B. So, what it says is, suppose A is congruent to B mod n. As per the definition, when we say A is congruent to B mod n should divide A minus B. I have already taken an element A and B which satisfies this condition. The meaning is I have taken AB which is in R. So the minute when I write AB belongs to R, that should satisfy modulus property. The meaning is n is dividing A minus B. Now we have to prove that as per the definition of symmetry, BA belongs to R. In the sense, in place of A, I should replace B. In place of B, I have to replace A. So that will become B is congruent to A mod n. Meaning is n should divide B minus A. Fine. Now we have to verify whether it is true or not. If it satisfies this condition, in the sense I have assumed that AB in R. So A is congruent to B mod n. As per the definition, n divides A minus B. If it satisfies reverse condition, that is BA is also in R, then it must satisfy this condition. If it satisfies this, then we can say it is symmetric. Now I'll give you simple counter example. Suppose I'm going to take the value of A as 9 and B as 3. And let me take n as 2. Fine. Now let me check first condition. 2 divides 9 minus 3. Is it true? 2 divides 9 minus 3 as per the first condition. 2 divides 9 minus 3 is 6. Yes, it divides. Now let me check the second condition. 2 divides 3 minus 9. Implication is 2 divides minus 6. No matter whether it is positive or negative, yes, it completely divides. So, since I have taken random values for A, B and n, it satisfies both the condition. Therefore, it is symmetric. Now, let me talk about transitivity. So, as per the property, I have to take 3 elements. So, let me take any 3 element in the set of integers. So I have to take AB belongs to R and BC belongs to R. As per the definition, AC should belongs to R. This is what the condition of transitivity is. Now let me check. Suppose if AB belongs to R, I can write A is congruent to B mod n. Right? Suppose if BC belongs to R, I can write B is congruent to C mod n. Now we have to check whether AC belongs to R or not. Let me solve that. Since A is congruent to B mod n, I can write this as n divides A minus B. Similarly, I can read this condition as n divides B minus C. Now, let me combine these two solution. So I can write, since n divides A minus B and n divides B minus C, in the sense n is dividing this value as well as this value. So by combining these two, I can write n divides A minus B and B minus C. Right? So it implies n divides minus B plus B get cancels. N divides A minus B. A minus C. So now let me put it in the standard form. So when n divides A minus B, I can write A is congruent to B mod n. So similarly, when n divides A minus C, I can write A is congruent to C mod n. Right? So the meaning is that AC is also in R. I have taken n divides A minus B and n divides B minus C. I have to prove n divides A and C as well. So I have proven n divides A minus C. So A is congruent to C mod n. Therefore, I can say R is transitive. Since it is reflexive, symmetric and transitive, therefore it is equivalence relation. Now, what about the antisymmetric condition? Now let me check for antisymmetric condition. So, as per the antisymmetric condition, when AB in R, BA in R, then A should be equal to B. Meaning is, when n divides A minus B, I am writing directly the condition. AB in R in the sense A is congruent to B mod n. I can write n divides A minus B. Similarly, n divides B minus A. Now we have to prove A is equal to B. The simple logic is that when n divides A minus B and n divides B minus A need not be equal to B. Why? Because let me give you a counter example. So I can give you a simple example. Suppose if A is equal to 4 and B is equal to 6. and let me take n is equal to 2. In this case, you can clearly note that n divides a minus b. That is first condition. 2 divides 4 minus 6. That is 2 divides minus 2. Right? And again n divides b minus a. N is divides b minus a. 2 divides 6 minus 4. That is 2 divides 2. No matter whether it is negative or positive, 2 is completely dividing 2. And 2 is completely dividing minus 2. But here you can clearly observe that both the conditions are satisfying. N divides a minus b and n divides b minus a. But the value of a and b are not equal. Since a is equal to 4 and b is equal to 6, though the value of a and b are not equal, this condition is satisfying. Therefore, it is not antisymmetric. Therefore, it is not antisymmetric. Hope it is clear for you. But the thing you have to remember is, when I said congruent modulo n, meaning is that a is congruent to b mod n. So you can take any one of the counter example to prove. Now, third example question for you. The question is bit different. Look at the question. Let T be a set of triangles. Here T is set of triangles. Define a relation R on T. In the sense, I am defining a relation R on a set of triangles such that T1 is related to T2. Meaning is T1, T2 belongs to R only when, if and only if, T1 and T2 have an angle of same measurement. In the sense, both the triangles and T1 and T2 have at least one same angle of measurement. I am just convincing the question once again. I have a set of triangles and I have defined a relation R on this set of triangles in such a way that T1, T2 belongs to R, in the sense relation R, whenever in both the triangles there is at least one same angle of measurement. In both the triangle there has at least one same angle of measurement. Now let me talk about the nature of this problem. In the sense, first one is reflexive. Test whether it is reflexive or not. Fine. For reflexive, how many triangles we have to choose? One triangle. It is something like an element. So I am choosing one triangle. So if I am going to, as per the definition, you just recollect the definition. If A belongs to R, A should also belongs to R as per the definition of reflexivity. So since I have taken a triangle T1 which belongs to a relation R, which is in a set, given set, then T1, T2 should, T1, T1, same element, right? Since I have taken any element A in a set A, then that element ordered set, that is A, should be in R as per the definition of reflexive. So I have to prove T1, T1. The same triangle belongs to a relation R. Is it true? Yes, it is. Why? Because, let me take one example. I am going to take a triangle 1, say A, B, C. Let me take angle A as 60 degree and angle B as 30 degree and angle C as 90 degree. Why? Because angle sum should be equal to 180, right? 6 plus 3, 9, 9 plus 9, 18. Fine. 180 degree. I have taken a triangle T1 in such a way that the angle of measurement is something like this. Now, I should take two triangles, T1 and T1, again with the same triangle, T1 and T1. 60, 90, 30. Clearly, in both these two triangles, at least one angle is same. Here, in this case, all the three angles is same. Anyhow, we can say at least one angle is same measurement. That is what the definition of given relation is. T1 and T2 should have, whenever these two elements belongs to R, only when in these two triangles, you should have at least one equal angle. So, that is the reason I have written T1, T1 is in R. I have taken a triangle. Again, I am talking about the same triangle. So, there is at least one equal angle between these two triangles. Therefore, T1, T2 the same triangle T1 belongs to R, therefore R is reflexive. In exam, no need to write the diagram and all. I am just writing it for your reference. Now let me talk about symmetric. So for symmetric, we have to take two triangles. Let me take T1 and T2. So when I write T1 comma T2 belongs to R, I have to prove T2 comma T1 is also in R to prove. Right? So when I said T1 comma T2 in R, implies that as per the given problem, T1 and T2 has at least one equal angle. One equal angle. Right? Now let me take two triangles, T1 and T2. Let me take the same triangle ABC with measurement say 60 degree, 30 degree and 90 degree. I have taken a triangle 1 and I should take triangle 2 in such a way that there should be at least one equal angle between them. That is what the meaning of T1 comma T2 belongs to R. Now let me take triangle 2 in such a way that, let me take this as 30, 70, this should be 80. Yeah, sum is 180, right? Let me take this as A, C, B. Now here angle B is equal to angle A. I have chosen two triangles T1 and T2 such that in both the triangles has at least one equal angle. Here in these two triangles, angle A and angle B are equal. Now I have to prove that T2 comma T1 is also in R. Now look at the same two triangles. First I talk about T1 and T2. First I have chosen this triangle with reference to this. Now let me talk about these two triangles. In this triangle, angle A is again equal to angle B. So no matter whatever may be the position, it has T1 and T2 has at least one equal angle. So when I talk about these two triangles, again reverse will be the same triangle itself. Then also it has two equal measurement angle. So therefore I can say it is symmetric. Now transitive. Now you will understand this problem clearly. So for transitivity I have to choose two pairs, three elements, in the sense T1, T2, T3 in a set. Fine. T1, T2 belongs to R. T2, T3 belongs to R. We have to prove T1, T3 is also in R. To prove this, right? I have taken two triangles. T1, T2 belongs to R. Implies that T1 and T2 has equal angle of measurement. Again T2 and T3 has equal angle of measurement. I have to prove T1 and T3 should have equal angle of measurement. Let me prove. I have taken two triangles here. Let me take these two triangles, T1 and T2. So it has at least two equal angle. So first condition is satisfied. Now let me take one more triangle. It is 80 degree, it is 60 degree, it is 20 degree. Right? Now in these two triangles T3, look at the triangle T2 and T3. So first condition T1, T2, it both has two common angles. So T1, T2 has equal angles, right? Again T2 and T3. Now look at these two triangles B and A. Let me take this as A. B and A is equal angle, 80 degree. Both are 80 degree, B and A. So T2 and T3 has at least one equal angle. Now what we have to prove is T1 and T3 should be equal. Now look at these diagram. T1 and T3. Now forget about this. Forget about this. Look at these two diagram. Do we have any common angle? 60 degree, 30 degree and 90 degree. 80 degree, 60 degree, 20 degree. We don't have any common angle between these two triangles. In the sense, I can clearly say T1, T3 does not belongs to R. Therefore, it is not transitive. It is not transitive. I'll just repeat once again. For reflexive, I have taken one triangle with measurement 60, 90, 30. Since I am talking about reflexive, I have to take the same triangle. So it has at least one equal angle. Therefore, T1 belongs to R. It is reflexive. For symmetric, I have chosen two triangles such that it has one angle should be equal. since angle B is equal to angle A. Again I am taking those two triangles, just reversing the order. Even though when you reverse order, there will be at least one angle which is equal measurement. Now coming to the transitivity, I have chosen triangle T1 and T2 which has 30 degree as equal angle. So it belongs to R. Next I have chosen T2 and T3 which has 80 degree common. Angle B is 80, angle A is 80 degree. So those two belongs to R. I have to prove T1 and T3 is also in R. But I don't have common angle between T1 and T3 which is different. Therefore, it does not belongs to R. Therefore, it is not transitive. Fine. Now, coming to the antisymmetric relation. So, for antisymmetric, suppose T1, T2 in R and T2, T1 in R, I have to prove T1 is equal to T2. Like AB is equal to R, BA is equal to R, I have to prove T1 is equal to T2. Clearly it is not equal, right? Let me look at these two pictures. See here, T1, T2 belongs to R. Why? Because it has one common angle. Angle A is equal to angle B. Let me write the diagram once again here. 60, 90, 30, 30, 70, 80. T1, T2 belongs to R in the sense I have taken two triangles T1 and T2. It has common angle. Therefore, it belongs to R. Again, when I am taking T2, T1, it has common angle. It belongs to R. But triangle 1 is not equal to triangle 2. Why? Because look at the remaining angle. 60 degree, 90 degree, 70 degree, 80 degree. They are not equal. Therefore, it is not antisymmetric. They are not equal. Therefore, it is not antisymmetric. I am just repeating antisymmetric once again. I have chosen two triangle in such a way that since I have written T1, T2 belongs to R, so it should has at least one common angle. Again I am talking about the same two triangle just by reversing the ordered pair T2, T1 as per the definition. So again it has common angle 30 degree. Now as per the definition of antisymmetric, they should be equal, but look at the diagram. There may be chances that it is 60 degree, 90 degree, it is 70 degree, 80 degree. They are not equal in the sense these two triangles are not equal. So when this condition fails, we can clearly say it is not an antisymmetric relation. Hope it is clear for you. Thank you. Continue in the next session.